All right, good evening, class. Here we go, lesson 4. This is my favorite lesson. Functions. It's all about creating reusable code. So here you can see in this lesson, we're going to talk about defining functions, local variables, global variables, passing arguments to functions, using the return function within a function. I'll cover the math module briefly, and storing functions in modules, which is nothing more than saving a file, a .py file with functions defined in them. But let's get to it, right? So hope everyone's doing well. I'm feeling a little better. I had a little bit of a cold earlier, and I'm still getting through it, but I'll be fine. Let me get rid of this. Put this over here. All right. So functions. Let's talk about what they are. So first off, you've been using them the whole time, right? Type, print, range, format, float. Those are built-in functions to Python. So if you were to go over here and if you pulled help on print, you'd see that it's a built-in function. Print module talks all about it, right? That now you're going to be defining your own functions. Of course, it's always better to use what's built first, or if it fits your needs, or if you know of a function within Python. But sometimes you got to build custom stuff. You know, more times than most, it just makes sense to build custom stuff that doesn't exist to fit whatever requirements you got going on. So it's basically a piece of reusable code. You know, you can call on print as many times as you need to. You'll be able to define a function, call on it an infinite amount of times. Cool thing about functions is you could define a function and then define another function and call on your other function. You could pass a function. You can get as creative as you want with this stuff, right? But first, before we get into that, we're going to cover min, max, and length, right? New functions. So max and min functions, you guessed it. It gives you the max. Here we have a string, hello class. S is the max, not because it's the lowest in the alphabet, but it's the ASCII ID of it, or the ordinal of it, or the character, I should say. So I think if we do an ordinal of S, let's see if this makes sense, gives us 115. 115 is the Unicode identifier of that character. And that'll make more sense as we go on. But one key thing here is ordinal and character, char, um, they're good to get information about an object, but I would hesitate to use them in reference to doing something like a Caesar cipher. I know some are going to use those, but I said don't, and I mean don't, because ord and char are great, but they're really out of the scope of this class. I'd rather have you learn the core functions of what we have going on within the fundamentals. So here we have a list of integers. And we say what's the max within the list, and of course 10 has the value of 10, which is the max, of course, of this, right? So if I were to just grab this and type min, and it tells us 5. Cool. And the minute hello class, we'll do that as well. We'll see it's the space, which I think is 23. But min, max, built-in functions, awesome to do really quick work. If you had a list of, who knows how many items in a list, max and min make really quick work of finding out which ones, the max and min. There's also an average command, which we'll talk about at another time. Now, the length function is a bit different. It tells you how many items are in the argument. So here we have length of hello class as 11, 5, 6, 7, 8, 9, 10, 11. Counts a space. A space is indeed an object. It's an object of the string class. That's why we have 11 there. Now we get the length of a list. Length of a list, count how many objects are in there. And you guessed it, 1, 2, 3, 4, 5. So length, min, and max, very helpful functions. They're covered in this chapter. And now we're going to move on to talk about defining our own custom functions. So of course they're all followed by the keyword of def, followed by the identifier name that you're going to give to it, then parentheses, which can hold the variables, and then a colon, which ends the line. And then underneath that line is where your statements go. So to put this in use, we'll do the very first one. I'll define, say hello over here. Define, say hello, open close parentheses, followed by a colon. I hit enter. Now you notice it's tabbed over. It's ready for this the script block. So I could say print, and we'll say, I'll just keep hello class, right? Now I got a syntax error. Why did I get a syntax error? Because I mixed my single double quotes. Enter again. No errors this time, so that means that say hello is indeed in memory. And you can do that by checking the ID of say hello. And you see that has a memory ID, so you know it's loaded. Now, if I just ran say hello and hit enter, it'll tell me it's a function. And of course, that is the hexadecimal location of the memory. Now, if I do open close parentheses, it'll run the function from memory. If I reset or close this shell or restart this shell and then type say hello, open close parentheses, it is not defined. Same thing would happen if I close the shell and reopened it. You have to redefine your function if you open and close the shell. Now, let's do this again. And you'll see that it's back in business. It works as designed. Cool. Now, what we have coming up here on the left side, you'll see that we have say hello takes a argument of X, and then we say for Y in range, print X and the function. Well, what would this do in theory? Let's cut and paste it. Let's define say hello one. Oh, there's syntax error. Let's see what happened there. Oh, you know what I forgot? Of course, Python's good enough to tell us. Colon. Now say hello one's in memory. Now you notice X takes an argument. It says for each iteration, start at 8, going to 0, print X. So we could say hello 1, and then give it the parameter of Steve. Now what happened? Why didn't it print X? Anybody know? We ran say hello Steve. That said for Y in range of 8 to 0, print X. Let's troubleshoot this for a second. Well, what if we change this to an integer, 3? Same thing. Let's talk about this. So X, do we have to do X equals? No, it's just a placeholder. So say hello X for Y in range of 8 to 0, print X. Trying to see where we're jacked up here. And of course, this is going to bother me. And of course, being sick isn't any fun. Let's just take a look at this. So we can do some easy troubleshooting. We would say X equals Steve. Now we can just do for Y in range, break out the code, see where we jacked up, right? And say print X. And there we go again. So nothing happened there. Nothing occurred. So if we call it X, Steve is there. So why is that? Was it a local variable problem? Is it a definition problem? Or do I need to rerun the shell? This is the one problem with idle as well. So let's really isolate all this. That should be green. And let's see if we can isolate all this. Oh man, there's more than that here, huh? Gotta love live demos. Let's just type it. Define, say H1, good enough. I'll take X. For Y in. For Y in range. For Y in range, 8, stop at 0. X. H1. Yeah, so let me think about this. Blah, 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 blah. Why isn't X passing? So X is a member of the for statement. Now, let's try something else. Let's do the same thing. And we'll do print X. Say H1. We'll say Steve is X. And now it works just fine. So that's an issue because the X is well, it should be a variable under the for statement, but it's not really available to the for statement because it's a member of the say hi value. So that was a bogus demo. We get the gist of it right now. If we take that same idea, we should be able to do something like define, say hello to, we'll give it X and Y. I'll say print, we'll say for each, item in range 0 through 8. X plus Y. So here I'm going to take two integers. We'll see how this goes. So here I passed the two integers. So 2 takes X spot and 3 takes Y. I said for each item in a range of 0 through 8. So it'll print 8 times. Print X plus Y. So I just called it my function, passed it 2 parameters to fill in the arguments, 2 and 3. So print 2 plus 3. And it did that for the amount of the range 5 times. Beautiful, right? Cool beans. Let's move on. So that's some parameters. We'll talk about more. Let's talk about pass. Say if you're writing a bunch of code, like open file, just do a new one. Just do new file new. So you got your header up here. You're writing some new code. You define, you need a function that does math, but you don't know what you need it to do yet. Like you're unsure of the future variables. So you can just type pass. Now, what that does is if you call on does math, it doesn't do anything because you didn't define it yet. And then you could define something else like function one, we'll say print test, and then we can call on function one. Has to be defined before you call on it. Now, if we call on does math, and I hit F5, you'll see that does math does nothing. and function 1 prints out test. Go away. So it works as designed. Pass is just one of those things that if you're designing something, you can always go back and fill in your pass or do a control F find pass, fill in the code you need, and then rock and roll. It's more of like I use it just as that during design. It allows me to remember to go back and complete my train of thought or my statements for the function. I meant to do something, I wasn't ready to, now I'm ready, right? That's fine, but it's available. Pass, you can also use it. It's kind of one of those things, if you find yourself using it, you may not need it. So if you just let it run, it's probably not best. This way, just print things. Just call on a function called print lyrics, and we print I'm a lumberjack and I'm okay. And then we have another function. We'll run that. So now we have print lyrics in memory, and now I'm going to have repeat lyrics in memory. So here we have one function calling on another one. So if I actually call on repeat lyrics, it calls on print lyrics twice. Sort of cool. But now let's talk about flow of execution. So up until now, most of your scripts have been running top to bottom as you write them like a paper until you hit a for loop or a while loop, and they sit there, complete the loop, and then they end. Functions, you could define functions all over the place and your code could call on them in any order, but as long as they're in memory first. So it adds a layer of complexity, but a good design goes a long way. Do not alter the flow of execution of the program, but remember the statements inside the function are not executed until the function is called. Like you have to define a function, give it some script blocks or statements, and then you call on it to run it. It has to be in memory first. We already called that, right? I don't really like this. It's calling it a detour. It jumps around. We'll write some more complex code. You'll see. Of course, the .py file is also called a module. And, if you fire an error, read it from the bottom up. That's always good to go. So let's see, we got test phrase. Yeah, here we go. So we got a print twice, right? Let's do this function right here. So we're going to define a function that prints twice. And of course, I didn't close it, so it's going to. And when we call on a print underscore twice, and we give it a string to print, this will print twice. You'll see that our define function takes the phrase or whatever argument and prints it twice. Awesome. All right. And here we have some other fun examples of spam and so on and so forth. Then we could print twice max the spam. So now we're starting to call on a function that we designed, and then we call on a built-in function against a string. So max should find the maximum element of my string and then print it twice. And that's exactly what it does. So that's kind of cool, right? We have fun with that. What else we have here? We got using a variable. Okay, so this is fun, right? So here you have print twice is already defined. It's already in memory. I'm going to create a variable called status and hit enter. It says this is a test. And I'm going to call on status. So now we're passing a variable as a parameter to my function, which then prints it twice. Awesome, right? Replaces the phrase with status, which is really, this is a test. Super cool. Multiple parameters, kind of already showed you that, but we could run through this one. This was kind of cool. So here we have a print max function. It takes two arguments. If A is greater than B, print as A is maximum. If they're equal, print they're equal, else B is maximum. So let's test this out. Let's say print max, and we'll go 10 and 2. So A is 10, B is 2, 10 is maximum. Let's do 10 and 10. They're equal. Let's flip this 1 and 10. 10 is maximum. So we ran through all the logic of that function. It works like a boss. Takes two arguments. We fill it with data. They become parameters. They get fed down. They replace the arguments in your design, and the logic it executes. Super cool. So this concept of fruitful functions. Fruitful functions leverage the return function and give you something back. Let me show you what I mean here. I'm not going to do that one. Let's do yeah, we'll go ahead and do that. So let's take a look at this return statement here. Print maximum, let's see, maximum 2, 3. Let's define it first. I want to show you what return really does. So we're going to define this. I'm going to hit enter. So we created a function called maximum. It takes two arguments, x and y. Obviously, they're integers. If x is greater than y, return x. So what does that return mean? Excuse me. Let's run maximum. Let's give it two parameters. Let's go 5 and 2. When I hit enter, 5 is returned. But we don't know what logic it hit, right? But we know that we wrote this and x is greater than y, return x. So we know that 5 is greater than 2, it returned x. So printed it out basically, but not really. It returned it to standard output. We could redirect this. We're going to do this again, same exact command, except I'm going to say var1 equals maximum 5 and 2. So var1 variable equals my function 5 comma 2. It's going to run it. We're good. Now if I call on var1, I have the value of 5 in it. So return within a function, you could store output from a variable inside a function. That becomes very powerful because then you could pass it to other functions after you run it. It'll be more clear the more you get to use this stuff, but your designs, say if you wrote a function called, do you want to play a game? Or play, yes or no, right? And you could ask them, would you like to play a game? Enter yes or no. Return the output is whatever variable you want. And then you could use that in your logic while you're playing your game. Then you can always call on that function again. Do you want to continue to play? And if they hit no, you can end the game. We could do all kinds of fun stuff by monitoring a particular variable for a certain value. It's just a bunch of print functions. It's no fun really. This is kind of a combination of hello2. We'll run this one. So here we define a function called hello2. It takes an argument called name, which could be anything. It could be x, y, but naming them makes sense. And here we say name, print hello plus name. So we call on hello2, and we pass it Steve again. And now we have hello Steve. Works as designed, right? Really not too bad. But remember the whole parameter and argument concept. That's it for starting the functions. Now, let's do this one. We already kind of did this. This is just define a function. Different arguments, and you assign them, they become parameters. So right here, when we say x, y, and z, that's the arguments of the function. Now, if we do a help on our newly created function 1, we'll see that it says, hey, it's part of the main module because it's in our main memory space right now. And function takes up to 3 variables. Well, 3 arguments, right? So here we have this right here. That's it. Just prints them out. Doesn't really do anything exciting. Prints them out backwards, right? Nothing too extravagant. But the terminology is important, right? When we say arguments, assigned a variable, it's arguments are these little jokers. When you assign them values, they become parameters. No big deal. A lot of people use them interchangeably, but that's all I'm going to say, right? Just know when to say, when you're designing a function, they're arguments. When you're using the function and filling it with data, they're parameters. So now let's talk about math module really quick. So let's say you want to do some complex math that Python doesn't do out of the box, but Python has a math module. Use import math, hit enter, do a dir on math, and you'll see all the fun stuff that you just imported into memory that's now available. Here you have power. So now I could say math dot power, and you could say 2 to the 4th, 2 to the 4th power, and that's like writing. It's like writing 2 to the 4th exponent, which is 2 times 2 times 2 times 2, which is 416, which is what we get right here. So a lot of fun stuff with the extended math module. There's even NumPy, which is advanced mathematics and usually used with big data platforms. We'll probably touch on that in lesson 8. But I know the book touches on the math. They call on power, square root, pi, and I think something else. But those are about it. And you can also get help on each of those as well. Let me get to the next one up. Oop. Let's see if we already did this. Yeah, we kind of already walked through this. Yeah, so let's talk about let's do a new file. Let's say we'll walk through just a name gather. Simple program gathers people's names, right? So we'll just say this is our header, and usually it's best to put global variables up top. What do I mean by global variables? Well, var1 equals nothing yet. This is a global variable. That means no matter what I define underneath it, we'll have access to var1 and what the object contains. Now, if I did this, define function1, open, close, then I did a var1 in here, and I had it equal test, and I say print var1, this is a local variable. var1 is local only to function1. And to prove that, I'll say var2, and I'll just print var2. And out here, I'll say print var2, and this should error. I'll do test2. And just like clockwork, what happened? It erred. It said var2 is not defined. And you notice it gives me the line number of 15, which is I'm on line 15. Never called on function1. It's in memory. Remember, Python loads your script top to bottom. And just to prove that, I could call on function1 right here. Looks a little sloppy. I'll give it some room. Same thing. So now function1 runs, prints out my test from var2, but when I go to print var2, this fails. This defines a local variable. var2 is only local to function 1. It can only be processed when function 1 is called. So how do you get global variables inside a local function? Like either pass them as an argument or a parameter, right? Or you can simply say global, then call on var1, right? And here we'll say test global. And now here, I'm passing the global variable var1 into my function of 1, right? It already knows what var2 is, but I'm also going to print var1. I'm going to comment this out so we don't get another error. Save, hit F5, and you'll see that I got my test from var2 and my global variable of test global I called from the global var value. Awesome. So global variables with now, if I comment this out, what happens? Still works. Now, why is that? Well, this is good practice. Necessarily, you don't have to do this. You could. This is how you can also define a global variable within a local function, and because var1 is global, and the function 1 has access to it, so you can call on it from external. It'll be fine. Now, I know that's a lot to pack in global and local space, but let's do global var3, and we'll say var3 equals odd. And now I'm going to print var3 here. Now you notice that the function 1 didn't call on var3, it just defined it. I used global var3, and then I said var3 equals odd, and then external from the function, I printed var3. We created a global variable inside a local function, which makes that variable available external to the function itself. So there's a couple ways around this. If you write easy scripts, like relatively easy, like we're just dealing with a couple IPs or maybe less than 25 lines of code or something, and you only define like 1 or 2 functions, you can get away with keeping most of your variables global. Like just define them all outside your function. If you do something special within a function to that variable, you don't want any chance of it being corrupted. Like if you're writing a function to determine amortized interest of mortgage loan, well, within that function, only amortized interest, you want a variable in there called like amortized interest 1, and you only want that function to deal with that variable, make it local, and then return that value outbound as a variable. So you can get really tricky with this stuff, and you're limited only by your imagination. Well, let's get back to doing something fun. So got some input. We'll say username equals, we'll say input, default is a string. What is your first name? Yeah, that's fine. It'll come as a string. That's cool. And we can also have a username. I'll call it F name, first name. User L name. And you can also learn how to break this stuff up and ask it in one question as well. What is your last name? So what's going to happen here? So we're going to have a first name, a last name, right? So what if we define a function and call it name builder. And it takes X and Y. And then it prints. Let's see how we want to do this. Your full name is, let me go, user first name, space, user last name, right? Now, do I need this or should I do X and Y? I should do X and Y. You'll see in a minute, right? This is all good, looking good, right? Just grab what's your first name, what's your last name, give a little welcome, print. Welcome to the name builder. We defined our function. Now we have to call on it, right? Well, this is where it gets tricky. So to save you from yourself, if name is equal to main, then we'll say name builder. And we'll say name builder. And now we'll call on our user f name and user l name. Let's see how this goes. All right. Save it. Hit F5. Welcome to the name builder. What's your first name? Zach. Enter. What's your last name? Whiten. Your full name is Zach Whiten. So it built my name for me. So let's talk about all this. So these are global variables that pull an input from the user. We defined a function called nameBuilder with X and Y as a print statement that prints X and Y. This line right here is a logic check to see if this name of test.2 or test2.py is in memory along with all of its contents in the main memory space of Python. Some folks say you don't need this line. Well, people writing generic code, running multiple scripts at the same time or near same time within on a server, not that they should run in the same memory space, but if it bleeds over, you have the opportunity of potentially having variables with the same name and the same space, sharing IDs. If someone else ran a file called test2 and I ran one called test2, and they're both running, that may cause memory issues. There's a lot of things that can go wrong. This line basically checks to make sure if you're available in memory, and if it all comes back good, and if it's true, it'll go ahead and run this script block, which is our function with the two global variables, and it performs that task for us just fine, right? Now, the cool thing is, you gotta say, like, print your first name is, your last name is, and now you can get would you like to, let's see, what can we do here? Define, we'll just call play again for fun. Play again. Oh, what if you don't like this? Well, then you can start to redefine your entire script. All right. So now you have welcome to name builder, first name, last name is part of name builder, and play again, which would call on name builder. Now, how would it do this? So would it call it just on name builder? Or does it need X and Y anymore? You see where you're getting into like this design phase where you have to go back and re-articulate your script or your parameters or arguments based on your design changing. So right here, I don't like this either. I'll tell you why. It's best to define a main function and then have your main function call in all your logic. Now, where'd you put play again? You could put it right here, right? Play again, right? Now I could say play again, user in equals input. Would you like to play again? Question mark. I can just give it a yes and no. Nothing crazy here. Now we can start to use logic here that we learned from throughout class. So we got a yes or no input. If user in is equal to yes, then run name builder, right? Else, what do you want to do? Exit, print. Thanks for using name builder 1.0. We'll see how this goes, right? So we got our main function, calls on name builder, calls on play again. All right. Got built our name builder function. It has our welcome. We could build a welcome function just to do the welcome. I'd like to do that actually. We might get to that. Input your first name, input your last name, print X and Y. When this name builder's done, well, this just goes into memory, doesn't do anything. Play again goes user input. Would you like to play again? Yes or no? If yes, run name builder again. Else, print. Well, play again has to go somewhere. It's going to run name builder, run play again. If everything's if this check is good, it's going to run our main function. Main is going to call on name builder, then play again. You notice it's no longer top to bottom. Goes in memory, goes in memory, goes in memory, calls on main, main triggers name builder and play again. And here we go. What's your first name? Zach. What's your last name? Whiten. Oh, what happened here? X is not defined. Everything's all broken, right? Remember that we swapped out these jokers. And this is design and redesign, right? It's normal. Don't be bad. You're not going to get it right the first time around. It's okay. I'm going to save it. We're going to F5 it again. I'm going to say Tim Smith. And now we're here. We're here. Printed it. And now we're here. It ran play again. And now it's asking me would I like to play again. And I'm going to say, yes, this is flow of execution. Oh, what happened when I hit Y? Oh, look, I missed a D in name builder. Bueller, name Bueller, Ferris Bueller. So now it should be fine. But let's give it another test. And this is perfect, right? This shows you that, hey, red's okay. You read the, now it worked out perfect, right? We corrected our mistake and we named name builder. Now, if you're using like a more advanced script writer, like Visual Studio or PyCharm, it would have caught that and fixed it for you. But this is idle. You get what you get when you type, and it's okay to make mistakes. So I'll do it again. Tim Smith. That's it. Now you notice when I did it again. After play again, it ran name builder, and then it was over. Now, how can I correct this to where what runs play again all the time? Well, instead of play again running main, what if I put it right here? inside my name builder function. So now, when I call on main will call on name builder, it'll gather your information, it'll print, it'll call on play again, then it'll ask you if you want to play again. If yes, it'll call on name builder, then it'll ask you to play again, name builder, play again, see what I'm saying? It's a loop now. So logically, we just made it go over and over. Let's see if it works. Yes. And now I'll say Liam. I misspelled that. It's okay. And now I'm going to say no. And then it exits as designed. Would you like to play again? No. This is a complete, like, kind of thought, right? It's best to use the main function to call in your defined functions. It's really easy to get away from this and not use this. But as your code gets more complex, say if you just wanted to create a welcome banner, well, you could just grab this, clean this up a little bit. Define welcome. Open, close. And then right here, you can welcome. Execute your welcome. If you wanted to exit, define an exit commit or function, put exit. Save F5. Tim Smith. No, we're good. So everything worked as designed. Still got my welcome. Created function. See how quick we did that too? Now the cool thing is, next week I'll show you how to call these in from another location. So it's much like import, right? Let's kill this, and I'll open up a new shell. And I'll call on name builder. We get an error, right? Now, what if I say import name builder from test2.py? Syntax error, that's my bad. I forgot, don't need these. Syntax here again. So what am I doing wrong here? I'm missing that builder. Invalid syntax. So let's talk about this. Here you have a bunch of red. I try to import a function from a file. Why is it failing? It keeps telling me invalid, invalid, invalid. Now, do I have to go from the file, import name builder? We could do that, right? I say from test2.py, import name builder. What happened there? No module named test2. This is important. All these errors are important. Let's talk about this. Most recent call, last call, file, PyShell, blah, 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 blah. From test2py, import name builder. No module found error. No module named test2. So this shell doesn't know what test2 is because I didn't give it this long path. This is called an absolute path when you have to type in everything. We'll dive deeper into that next week. We'll rip that apart. But just to set you up for success, always use the main function. Always use mainline logic. When I talk about mainline logic, it's if name equals to main, and the double underscores are called dunders. If dunder name dunder is equal to dunder main dunder, then you call on your main function, and you rock and roll from there. This is a lot of fun. It doesn't cost anything to create custom functions. As you can see, we created 1, 2, 3, 4 custom functions on the fly really quick. Remember, your global variables and local variables are two different things. Remember the return function. Let's see, what can we throw in here? Welcome, print. Returned. So the cool thing is, I mean, you can get tricky with return too, but we'll talk about more and more next week. I'll let you get comfortable with everything we discussed so far this evening, which is quite a bit. Min, max, length, how to define a function, global space, local space for variables. We talked about arguments and parameters, as well as how to pass functions those parameters. And then we built a little name builder script, and you can take it from there. You get more comfortable as the week goes on. I'll add more and more to it, and I'll upload some videos along the way. So have a great evening. And we'll go ahead and stop the share. I'll just set the whole meeting. Take care, everyone. Have a good night.